Your latest infrastructure project is running over budget and behind schedule. The cause is familiar. Fragmented 2D drawings create communication gaps between teams, leading to on-site clashes that no one anticipated. This traditional workflow is fundamentally flawed, costing firms both time and money. It is a persistent issue that has challenged civil engineering for decades. Imagine having the ability to identify every conflict, every utility line, and every structural component in a single, shared digital environment before construction begins. In this video, we explain how Building Information Modeling, BIM, moves beyond basic 3D modeling to serve as the central nervous system for your project, exposing critical gaps in design before they become costly problems. So, what is BIM? Building Information Modeling, or BIM, is not just 3D modeling. It is a collaborative, data-integrated approach to planning, designing, constructing, and managing infrastructure. In a BIM environment, every element in the model is an intelligent object rather than a simple geometric shape. A pipe, for example, is defined by its material, manufacturer, part number, installation requirements, cost, and installation method. This information is embedded directly into the model, creating a single source of truth for all project stakeholders. When a change is made, such as modifying the diameter of a pipe, that adjustment is automatically updated in every view, drawing, schedule, and quantity list. Everyone involved in the project accesses the same continuously updated data, which eliminates the risk of working from outdated documents. Understanding why BIM is changing the way civil engineering projects are delivered begins with its practical benefits. BIM creates a unified environment where all project data is stored and managed in one place. Every drawing, schedule, and quantity takeoff is linked to the same model, ensuring that all stakeholders work with the same updated information. For example, when an engineer changes the slope of a stormwater pipe, this adjustment automatically updates in the cross-sections, the bill of materials, and even the excavation quantities. This level of integration drastically reduces manual coordination that is common in traditional workflows, where design teams often rely on phone calls and emails to share critical updates. One of BIM's most powerful functions is its ability to detect conflicts before construction begins. Software like Navisworks or Revit can run automated clash detection on a federated model that merges architectural, structural, mechanical, and civil designs. A clash report identifies the exact location, elevation, and elements involved, allowing engineers to fix the problem during the design stage. A real-world example is the detection of a storm drain crossing a sewer line at the same depth. Without BIM, this would only be discovered during excavation, leading to costly field redesigns, work stoppages, and change orders. Resolving the issue digitally costs only a fraction of what on-site corrections would require. The construction phase is the most expensive time to make design changes. BIM minimizes this risk by allowing teams to visualize, test, and coordinate every component long before procurement or construction starts. A clash that costs a few hours of an engineer's time to fix in the design stage could easily cost tens of thousands of dollars in field rework, especially if it involves underground utilities or structural modifications. By preventing procurement mistakes, such as ordering an incorrect pipe diameter or mismatched structural components, BIM directly reduces wasted materials and labor costs. Because BIM provides a single source of truth, communication between design engineers, contractors, and project owners becomes much clearer. Instead of sending static PDF drawings, teams can share live BIM models where every update is instantly visible to all parties. Contractors can virtually walk through the model to understand installation sequences, while owners can review real-time progress. This transparency builds trust among stakeholders and reduces disputes over who is responsible for design errors or misinterpretations. BIM models allow stakeholders to virtually explore the project in 3D before construction begins. Complex systems, such as underground utility networks or mechanical plant rooms, can be reviewed in detail, making it easier to identify potential access issues or maintenance challenges. Owners and non-technical stakeholders benefit from this visual clarity, which helps them make informed decisions about design changes, materials, or construction sequencing. The benefits of BIM extend beyond design and construction. Once the project is complete, The BIM model serves as a digital twin of the built asset, containing detailed information such as equipment serial numbers, maintenance schedules, and replacement parts. Facility managers can use this data to plan preventive maintenance, manage energy efficiency, and quickly locate components for repair. This transforms BIM from a design tool into a long-term asset management system, delivering value throughout the entire lifecycle of the infrastructure. The advantages of BIM are clear, but the real challenge lies not in understanding its value. The difficulty comes from overcoming the operational and financial hurdles of implementation. Full adoption requires significant investment in software such as Civil 3D for detailed engineering, InfraWorks for conceptual planning, and Autodesk Construction Cloud for collaboration. These tools require substantial upfront costs. Beyond software, firms must dedicate many non-billable hours to staff training, developing new internal standards, and adjusting established workflows. This process often diverts key personnel away from revenue-generating work, causing a temporary drop in productivity and disrupting established project delivery routines. For many firms, the practical solution is to collaborate with specialized outsourcing partners. AXA Engineers has become a trusted choice in this regard, not only because of its technical expertise, but also because every project is executed on fully licensed software, including Civil 3D and InfraWorks. This ensures accurate, high-quality deliverables and strict data security, allowing firms to access consistent quality in all deliverables that support BIM-related workflows. These barriers explain why many firms continue to rely on traditional workflows, even when they recognize the limitations. In conventional design processes, data exists in separate silos. Drawings, spreadsheets, and schedules are managed independently. When a design change is introduced, such as modifying the slope of a utility pipe, the update does not automatically appear in all project documents. Different teams often work with different versions of information. Engineers use one set of data, procurement teams refer to another, and construction crews follow yet another. This inconsistency leads directly to expensive mistakes, rework, and disputes during construction. BIM exposes these long-standing gaps by replacing fragmented workflows with an integrated and information-rich environment. A single change is automatically updated in every related drawing, schedule, and quantity list, ensuring that all stakeholders rely on the same current information. Automated clash detection identifies conflicts such as utility crossings or structural interferences during the design phase, which greatly reduces field rework and prevents costly change orders. High-quality supporting services remain essential for BIM to deliver these results. Land survey support provides accurate topographic data, subdivision engineering ensures well-planned layouts, and public work documentation creates reliable references for infrastructure connections. AXA Engineers has extensive experience in these areas, contributing to more accurate and reliable data for BIM models. More importantly, BIM turns these weaknesses into opportunities for improvement. Centralized data improves collaboration, supports faster decision-making, and increases transparency throughout the project lifecycle. The information-rich model also provides long-term value after construction. It functions as a digital twin of the built asset, storing detailed maintenance and operational data that supports preventive maintenance and efficient asset management. Land development planning, detailed civil engineering design, and Civil 3D modeling play a critical role in this process. AXA Engineers, with its proven expertise in these services, delivers coordinated and accurate outputs that enhance the effectiveness of BIM-based workflows. The gaps in traditional civil design do not reflect a lack of engineering talent. They are the result of outdated processes. BIM does more than address these gaps. It changes the way projects are planned, designed, and maintained, setting a higher standard for efficiency, accuracy, and innovation in civil infrastructure. Relying on specialized support services, including those provided by AXA Engineers, allows project teams to transition smoothly from conventional methods to integrated information-driven project delivery while maintaining a high level of accuracy and constructability.